Hi everyone, welcome to Lab 5. This is Max here. Let's go. We're going to start by talking about our MATLAB simulation. Here we can see our thin red line is our steady state response at 5 volts. And with our 10 kilo ohm resistor shown in blue, we're going to reach that 5 volts much faster than our 100 kilo ohm resistor shown in red. This is because our time constant tau is related to the resistance times the capacitance. So a lower resistance means a lower time constant. Here is my basic RC circuit. You can see my resistor here, my capacitor here. Here's my Arduino code. So first we assign pins, then we assign the values of R, C, and tau. Then we set our delay value to tau over 50 as specified. Then you can see in setup, we set V in to low and delayed for 5 seconds to let our capacitor charge. So the main code, the loop, consists of two very similar while loops. The first is with V in being high and the second is with V in being low. What we do in these loops is read V in and VC, print them to the serial monitor, and then delay by a specified value. This value is that 1000 times delay value, which was tau over 50, 1000 to convert to seconds. And then when our timer reaches more than 10 times tau, we then move on to the next loop. And then we just keep repeating this process. Looking at our serial monitor, we can see V in is at 1023. Now it's switched back to 0, and our VC is dropping. It's eventually the V in is gonna switch back to 1023 and V in is gonna go back up and approach 1023 as we would expect. Now for our processing code. Changing out the processing code was pretty simple. All we did was add 6 rectangles to represent the lines from 0 to 5 volts and then 6 labels for 0 to 5 volts. Seeing this in action for the 100 kilo ohm resistor, we're gonna follow this RC circuit trend to approach our 5 volts, and then it's going to change back down to 0 volts, and then it's going to approach again. There it goes. And now this is with our 10 kilo ohm resistor. As you can see, it follows the same trend, but the time constant's a lot smaller, so everything is happening a lot faster. So I did a little bit of editing to the MATLAB code. First, I had to multiply V in and VC times 5 over 512 to convert to volts. I had to change my Y label to volts. And then I basically copy and pasted the whole code for circuit 1 and circuit 2, changing the parameters for resistance. So we pretty much got exactly what we expected. For each of them, you can see that general RC behavior where we're going up towards the steady state and back down towards the steady state as the steady state changes. The main difference obviously is that with the 100 kilo ohm resistor, we're going to have a much larger time constant, so everything's going to happen much more slowly. And then with the 10 kilo ohm resistor, we're going to have a much smaller time constant, so things are going to happen much more quickly. So now we've got our thermistor circuit set up with our 10 kilo ohm resistor. So right now we're going to heat the thermistor, imparting a step function. Careful. We can see the voltage decreases. And then the reason that the voltage is decreasing is because our thermistor's resistance is increasing. So the V0 taken at the middle point of the voltage divider is going to be decreasing. And right now it's pretty much returned to that 2.5 volts steady state value. We can ignore the green measurements. Those are left over from the other part of this lab. So now we're going to cool the thermistor. With this ice cube. So I'll get everything in the screen. And you can see that the voltage is increasing as we would expect. It's kind of hard to hold the ice cube in place, but I'm going to let go, and then it's going to slowly come back down to steady state. So we got the behavior we would expect with an RC circuit, that quick logarithmic jump. So like we said before, looking at this equation, when the resistance of the thermistor increases, aka we're increasing the temperature, V0 decreases, and when our thermistor decreases, cooling the thermistor, V0 increases as we got. So that was way easier to see with the heating of the thermistor, but the idea is the same. When you have an RC circuit and you give it a step function, it's going to have that logarithmic jump and that asymptote into that steady state until the steady state changes. And that's all for Lab 5, guys. Thanks for watching.